everyone. My name is Andrew,
I'm Colin.
And I'm Allison.
and the company we had the pleasure of working with on our capstone project is Syngenta, which is an agricultural business specializing in seed and agricultural chemical development and production. The project, as presented to the team by Syngenta, is focused on the development of new corn hybrids.
The problem is an observed discontinuity of overall performance, with performance being measured by yield in bushels per acre between the different stages of development of a new corn hybrid. For example, a new hybrid performs very well in early development, only to underperform in later stages of development, or vice versa. This is important because Syngenta uses these stages of development to determine market viability of a new corn hybrid.
The hypothesis presented to the team which explains this phenomenon is that an effect exists in earlier stages of development when smaller planting configurations are used, which causes hybrid yields to be artificially high or low, and this effect isn't present when larger planting configurations are used. The objective of the project was to evaluate the existence of this unknown effect, and if it exists, to attempt to quantify the effect in a way that could be used by Syngenta in their development processes.
Based on this hypothesis, the team determined that the effect could be coming from a general neighboring effect. Essentially, an effect derived from the competition between genetically different plants, which are planted very close to each other, causing artificial performance in earlier stages that is not present in later stages due to a lack of competition between genetically different hybrids. It was determined that the best way to quantify this competition neighboring effect was to use the observed yield of each plant when compared with the observed yield of each neighbor plant. When the plants don't have neighbors in a similar fashion as type A or B, as shown, the overall yield decreases. The differences between subject and neighbor yields were then used to construct an equation which provides an adjustment to the subject plant yield, which accounts for the competition neighbor effect.
The result of this analysis was a strong observable relationship between the difference in a subject plant's yield and its theoretical true yield as a function of the average difference between a subject plant's yield and each of its neighbors' yield. The results of graphing this equation demonstrate a strong relationship over the range of values. When this function is used to make adjustments to a subject plant's yield, it reduces the distance between observed and true yield on average. This is beneficial because when a hybrid's yield accurately represents its hypothetical true yield, Syngenta is able to make better decisions about which plants to advance through its development process.
The impacts of this project lie in more efficient utilization of currently employed resources. While it is not the intention of Syngenta to reduce resource utilization, such as plantless plots to reduce costs, improving the data input to their decision-making processes will facilitate the right plants being advanced. It has been determined that based on a minimum approximate error percentage of 10% in their decision-making processes, Syngenta could realize a benefit of $96,000 per year in more efficient resource utilization. It is understood by Syngenta that more research is needed on this topic before implementation, and Syngenta intends to continue to pursue the project and achieve higher confidence in the model so that it can be used in their development processes.